Hi, Twitch Universe. Glad you are here to join us for our second episode of Building Happy Little APIs. You may not know me really well, but there are a couple things that'll help you out. When I hold up one finger and I say second, I mean second. Sometimes that's confusing. Those are the rules. This is any number I want it to be. That'll help you out. There's more rules, but we'll cover that later. First, let me introduce over here to my right here, Mr. George Mao. George, tell us about yourself. This is my co-host.
Hi, everyone. My name is George. I am a serverless specialist at AWS, and I help our customers build all kinds of serverless solutions.
Excellent. And George is a rock star at API Gateway and is going to be helping us out today. So what we're going to do today is we're going to be talking, again, like I said, this is the second episode of Building Happy Little APIs. We want to help you stay calm. We want to help you stay peaceful. We want to help you build APIs and conquer the world. Happy little APIs. So today, we're going to be starting out with one of the most common use cases that we see, but really just a small percentage of the power of API Gateway. But today, we're going to be building a REST API. We're calling this No Rest for the Weary. And so before we get started with that, though, I want to kind of introduce you to SAM. And if you've never heard of SAM, this is going to be, it's a really powerful tool. It's the serverless application model, and we're going to be using SAM today to build out our application model, to build out our API gateway. In the last episode, we talked about the different ways you can use a CLI, you can use SAM like we're showing here, you can use the console, you can use CloudFormation, and you can use Swagger. Today we're going to use SAM because it integrates well with the other services that we're going to be bringing up, like Lambda. So let's jump in a little bit and just give you a quick overview of SAM and what it does. So the first thing to note is SAM is an AWS CloudFormation extension optimized for serverless. It has special serverless resource types, functions, APIs, you can see, that help you build serverless resources faster. It supports anything in AWS CloudFormation, and so if you use something in CloudFormation, it can go right into SAM. And it has an open specification. And you can see there's a link there, serverless / SAM there. So to get an idea here, you can use a lot of the same power that are CloudFormation, or the CloudFormation uses. It can mix in other non-SAM CloudFormation, S3, Kinesis, things like that. Supports use of parameters, mapping, and you can use like the import value. And there are some limitations to that because it does go through a transform. And then you can use YAML or JSON. Virtual show of hands, I'd be curious to know, or maybe in the Twitch chat, who uses JSON, who uses YAML. I'd like to see that, get a count on that. So if you take a look, this is what a SAM template looks like. And so what we're able to do, this particular SAM template is going to build a function and a table. And really interesting here is that it's a much shorter amount of code or lines used here in SAM than you would use in normal CloudFormation. And so the way this breaks out is you have the top part. And so it's very important, the transform, it says, this lets CloudFormation know this has to go through a transform. And then this middle resource is going to build a function, and the last resource is going to build the table. So you kind of get this idea of SAM and how it works. And so what ends up is this template over here becomes your architecture. So it's truly infrastructure as code. So that's a really high-level overview of SAM and how it works. If you don't use SAM, I really would encourage you to dig into it. It's a great way of modifying. George, what do you think? Anything you want to throw in there before we move on?
Yeah, I think SAM is a really cool tool to get started really quickly and not have to handle a lot of the little details about CloudFormation.
Yeah, what we're showing here is most of the SAM templating. There's also a partner to it, the SAM CLI, which we're going to be using quite a bit, and you'll be showing that off. But before we get there, let's talk about the architecture that we're going to do. Now, I want to reiterate, as we go through the next 12 episodes, this is the second of 13, so we have 12 more episodes. We're going to start with, like I said, building REST API, and we're going to get more and more maybe complex isn't the right word, but we're going to show more and more how API Gateway can handle everything regarding to APIs. And so today we're going to kind of set that base and kind of explain, again, the most common use case, or one of the most common use cases, which is the REST endpoint. I've also heard it as an HTTP transfer, or proxy, different things like that. So our architecture is really simple. So you think about this architecture, it's literally two services right now. Number one, we're going to use Amazon API Gateway, because it wouldn't make sense to talk about Amazon API Gateway without Amazon API Gateway. Number two, we're going to use a Lambda function. And then really any client can hit these. And so what we're going to do is at this point, I'm going to turn it over to George. And George is going to be showing some code and walking through exactly what this looks like, and give you a demonstration of how it can be done.
All right, thanks, Eric.
Periodically.
Cool, so I'm going to share my screen and flip over to my Visual Studio Code. So Visual Studio Code is actually my favorite IDE for building serverless applications. It's a very lightweight IDE, has a lot of cool plugins. So if I type in the bottom here and I type SAM, I already have SAM installed. So the SAM CLI is giving me some information about how I can use the CLI. So the first thing I want to do to start a new project is do SAM init. And SAM init will bootstrap my application and give me all the basics in order to run a SAM application locally. So when I do this, on the left here, we can see that a directory called SAM app is auto-generated, and we automatically get a template.yaml file. And this template.yaml file is exactly what Eric was mentioning earlier. It defines a simple Lambda function, and we can tell it's a Lambda function because it's type AWS serverless function. And this function is actually using a Node.js 8.10 runtime. So we could have used Python, we could have used any one of our other supported programming languages for Lambda. And what's important here is this Lambda function is wired up automatically to receive an HTTP REST request from an API gateway endpoint. And that path is going to live on /hello. We're going to be responding to a get method. So this method could be any standard HTTP method, but this is going to be a get method. Now, if I open up my hello world directory, this is where my application is implemented. And my SAM template is telling us that we have a handler method. So the handler method is the entry point to my Lambda function. So it's going to be in a file called app. And inside app is going to be a function name called Lambda handler. So if I open up that file here on the left, app.js, I see a function called Lambda handler. And this is where execution will begin for my Lambda function. And if we look at this application, it's very simple. It requires a simple package called Axios, and all it's going to do is basically reach out to Axios and then get my IP address. So it's very simple, and then it's going to construct a response with a status code of 200, so an HTTP 200 OK, and then the body is going to say a simple message of hello world along with the IP address of my current machine making that request. So it's a pretty simple application. In order to run this, I need to use another command called SAM build. So SAM build will actually zip and compile all of my deployment artifacts and give me another directory. So you'll see another directory show up.
Hey, George, it looks like you need to go into that directory.
Oh, sorry. Yep. So I'm in the wrong directory, so I need a cd into sam-app and then do my SAM build. Okay. So now SAM build is running. In about 10 seconds, we'll have a fully compiled and ready to go application underneath this folder called .aws SAM. Right, so in order to invoke my function, I'm going to run a couple commands. So I have a little cheat sheet here. The first thing we have to do is run this command, SAM local generate event. So SAM local is our local implementation of Lambda and API Gateway. So the generate event parameter generates a mock event source that will be hooked up and allows you to pass it to your Lambda function. So I'm actually going to generate an API Gateway event type and write it to a file called event.json. So I'll do that, and I get another file called event.json, and this is the exact HTTP event that will be passed into my Lambda function. So it's got a couple things on it. It's got a request context attribute, it's got some query string parameters, a bunch of mock headers, and the HTTP method that's going to be used, as well as the path that we're going to use to invoke this function. So in order to invoke this function, I'll run another command, which is also a SAM local command. So SAM local invoke is what's going to invoke my function locally on my machine. So I want to invoke a function called hello world function. And that name of that function is tied to the name that I give it in my SAM template. And then I want to pass it one parameter, which is my event parameter. So event.json, and hit enter. So this is going to spin up that local Docker container and execute my Lambda function. So once I did that, we
George,
see a
let
couple.
me interrupt you here. Sorry, I was going to interrupt. So when you run it with this, so you run that invoke, is it reaching out to AWS at all?
No, not at all. So this is actually running everything locally on my laptop using a Docker image that's downloaded and installed. So it looks just like Lambda, so you can have a really powerful dev environment without ever uploading to AWS.
Right, and that's a really good clarification to make. I think sometimes people get hung up on, all right, when I'm running this, when is it calling out to AWS? When is it running local? And for the Lambda part of this, you can involve other resources for testing things like that. But when we're running that API gateway in Lambda locally, that's all it's doing is locally. So
exactly. Yep. So let's take a look at some of these outputs in green. Now, the three most important lines in a Lambda function are going to be your start, end, and report line. So start is just like it sounds, is where your function began, and end is also where your function ends. But the report line tells us a couple metrics about how long my function took to run, so 280 milliseconds in this case, and also the memory used. So this function took about 33 megabytes to run. So down here is actually the log output for what happened within my function execution. So we see here that it has a body that's just saying message hello world, and then it's returning the location. So 72.21.196.65 is the local IP address that my machine is currently on. So what we just did was invoke a Lambda function locally on my machine, but what I want to do is run API gateway locally as well, because I want to test my resources locally. So to do that, there's another command called SAM local start API. So SAM local start API will bootstrap everything and run a local instance of API gateway. And what we'll see here is that we now have the function and API gateway mounted on localhost, so 127.0.0.1, and then it has a path hello world. And that path is exposed because we defined it here in the template.yaml file. I could have defined that path to be anything, but in this case, it's a hello world path. So if I click on this, it'll bring me to my browser, which will automatically invoke my function. So my browser is performing an HTTP GET request here, and I'm seeing an internal server error. So the reason I'm seeing this right now is because my function actually took longer than the maximum duration to run that I allowed this function to execute in. So up at the top here on lines 9 through 11, you can define some global attributes on things like timeout, environment variables, those types of things. So by default, every Lambda function has a 3-second timeout. So I'm going to boost this to 10 seconds and rerun this. So to rerun this, I need to do a SAM build again, and then a SAM local start API. So this gives my function a little more time to run and gives it the timeout a little bit of extra time to perform the actual request. So same thing here, I'm going to click on the hosted hello world path, and this time we should see a IP address come back, which is an execution from my browser invoking an HTTP GET request against my Lambda function. So yeah, now what you're seeing here is I have a plugin installed that's making the JSON data pre-printed. So this is a message of hello world with the location of my IP address, 72.21.
I'm going to jump in real quick here. We have some questions on why that's taking so long. One of the
Yeah.
things I would point out is this is making an API call out to a service that responds with a public IP. And so the delay is not the local machine, it is the actual API call and the matter of how fast that service is. Um, and so, and George is right in looking, okay, timeout, we're timing out pretty soon. I would encourage you guys on the next episode on May 14th, we're going to be talking about how do you find these kinds of things using, logging and tracing and X-ray and different things like that. But to answer the question we're seeing on why does it take so long, it's not George's fault is really what it is.
Cool. Thanks for the explanation. So, all right. Now, if I go back to my Visual Studio Code environment and I look at this environment here, we can see a couple things in here. We can see the Lambda functions that have been running and how long the execution took. So in this case, it took 3,899 milliseconds, right? So the next thing we're going to do is we're actually going to shut this down and implement the weather service that Eric talked about. Now, our weather service is going to be implemented in the JavaScript Lambda function here. So remember, this code here is a stubbed piece of code built by Sam and Nit. So I want to get rid of this code and then paste in something that I've already written that will perform my weather API. So I have a little piece of code here. I'm just going to copy all of this code from my cheat sheet, and I will replace the default code here. And then we'll take a look at what this code is actually doing. So, all right. So the first thing I do on line 43 is I'm creating a conditions array. And this conditions array is simply just all possible weather conditions in text format. So clear, partly cloudy, light rain, thunderstorm, overcast, those type of things. So my Lambda function on line 50 is going to grab the zip code from a query string parameter. So event.queryStringParameter.zip. So it's going to look for a zip parameter on the HTTP request. And then it's doing a little bit of error checking. If it can't find that parameter, it'll throw an error. And then on line 57, we'll generate a random temperature reading from 0 to 100. And then finally, we'll construct the response that's going to go back out to the HTTP caller. So in that case, I will send a status OK, 200 OK, and then I'm going to create the body. So the body is just going to be one of those conditions, one of those random conditions. So we're not actually hitting a weather API here. We're just mocking and stubbing out possible weather conditions. And in one of the later episodes, we'll actually perform this in real time. So the body consists of two attributes, conditions and the current temperature. And the temperature, remember, is going to be a random number generated using 0 to 100. So I'm going to save this real quick. And
Hey, George, I'm gonna throw in real quick here. Do you have your weather examples back on the app.js?
Yes.
Okay, can you go back there for a second? You have the weather. So there's some complaint that those are better weather than what they're seeing in Seattle. So just to throw this out, this may not be exactly accurate, and I wouldn't plan your picnics based on what you see here.
Yeah. Okay. So we can easily add, Seattle weather conditions here into the array and see what happens.
Yeah.
But okay, so I want to flip to my template.yaml file, and I actually want to make a couple changes here because we're no longer doing a hello world function. We're doing a get weather condition. So instead of this path that says hello world, I want to say get weather. So when I do that, my HTTP request needs to be against get weather and not hello. So I'm also going to change this out down here, get weather, and at this point, I'm ready to go. So I'm going to do a SAM build, and SAM build, remember, will take my source code, create a copy, and then compile and make it ready to deploy. So same thing, I can do SAM local, start API, and then it's going to bootstrap my API gateway instance as well as my Lambda function. And now notice that this is a little bit different here. We have a /get weather path because my template YAML file changed. So if I click on this, this will bring me to my browser, and we're no longer making that random HTTP call to an IP service. Instead, we're hitting my Lambda function that's going to perform this mock weather location. So I actually see an error here, location not found. And I'm expecting this because I'm not passing in a zip code. So if we go back and look at my source code here, go to my app.js, we're looking for a zip code. And then if zip code is null, throw an error. And if an error has been thrown, I have a catch block here that returns a status code of 404 not found and location not found for the error message. So that's why we're seeing that here. So if I actually pass in some data that is valid and hit enter here, zip equals 20171, and then this will hit my Lambda function and then randomize some mock weather data. So let's see this in action here. So it's telling me that my zip code in 20171 is thunderstorm and 67 degrees. Now if I change this, it's actually somewhat accurate here, but if I change this to 90210, we should see a different set of weather conditions fully randomized by my mock Lambda function. So let's see. Now, what you're seeing here is a pretty print of the JSON that actually got returned. So if I go over to the raw data, this is the real JSON that was returned. And this browser plugin is just doing the parsing and making it easy to read. So when I put in a new zip, I got clear, weather conditions are clear, and it's 28 degrees. So I hope it's not 28 degrees over in 90210, which is somewhere in California, right?
Celsius.
Yeah. Okay. So at this point, we've implemented our mock weather API service, and everything is local. Everything runs on my machine. So what I want to do now is I want to deploy this application out to AWS. So in order to do that,
Hey George, I'm gonna interrupt real quick. Can you collapse your sidebar? My eyes are old. Can you make your text a little bigger?
Oh yeah, sure.
Thank you.
Yeah, make it a little bigger. Look okay?
Yeah, in the browser specifically.
Oh yeah, sure.
Thank you. Sorry, okay. Guys, housekeeping for Eric's old eyes.
Yep. Okay, so let me start this terminal kind of messed up on me because I changed the.
You can blame me for that, aren't you?
Yeah, I changed the visual interface here. So, okay, so I'm ready to deploy this application. So we're going to do a SAM package. And SAM package is a CloudFormation alias. So if you're familiar with CloudFormation, package will zip and create a deployment package that will go out to CloudFormation to deploy my entire application. And the --S3 bucket actually shows it's where I want my deployment artifact to live. So this is actually going to put my zip file that's created by this CLI command into Gmal temp files, and then it's going to return to me a file called package.yaml. And package.yaml is the deployment artifact that's ready to go and ready to be executed by CloudFormation. So the next command I'm going to run is sam deploy. So sam deploy will take that package.yaml file and then deploy that entire artifact according to my specifications. So I give it a stack name called demo-stack. And this is just a stack name that CloudFormation will create and reference. You can choose any stack name that you want. And then I have a final --s capabilities flag. And this one is anytime I want to create IAM roles, I have to tell CloudFormation that I'm allowing it to create these roles. So when I do this, this will actually execute and deploy a CloudFormation stack that will contain my entire application.
So while we're waiting for this, can we go back to the template? I want to ask a couple of questions on that and point out some things. So when you say roles, where is the role being created in this template?
Yeah, good question. So if you notice here, under the resources section, we're creating a Lambda function, and that's it. So behind the scenes, SAM will automatically create your IAM role for that function on your behalf. So you don't have to specify that here. Now, if you want to modify the default permissions, you'll have to modify the policies that get attached to the role. So by default, everything is generated for you.
So do you know what the default permissions are?
Yeah, default permissions are going to do a couple things. It's going to allow you to execute the function. It's
Okay.
going to allow you to log to CloudWatch logs, and that's basically it.
Okay. And with the attachment of the events, is it gonna entitle that to trigger the Lambda?
Yes.
Okay. All right.
Yep. Cool.
Okay.
So now we see here, waiting for change set to be created, and this is really just polling CloudFormation for updates, and we finally see it successfully created an updated stack. So I'm going to go back to my CloudFormation console, and we should see a stack in here that says demo stack. So my first stack here, demo stack, I'll click into this, and there's a couple of tabs up here. The one that I'm interested in is going to be the resources tab. So the resources tab shows me all of the different resources that were created by this CloudFormation stack. So number one, we see a Lambda function called hello world function. I'll go ahead and load that up. And I also see a REST API here, serverless REST API. So I'll load that up as well. And then here, this is the role that Eric was talking about. So SAM automatically created this role for me that has those default permissions on it. So if I go look at my Lambda function, this Lambda function tells me that it belongs to the CloudFormation demo stack. And if I look at the code down below, this looks exactly like the weather application that we implemented. So this is deployed from my local SAM project up to CloudFormation and now belongs in Lambda. So
Can I edit that there?
yeah, so this is actually a fully functional IDE sitting right here, and it has everything from syntax highlighting to dot completion, and you can edit this just in line and then save and test right here. Very simple to do. Yeah.
Okay.
Cool. So the second resource that I opened up was my API Gateway resource, and we named it Demo Stack. So Demo Stack has a /get weather as a path, as a resource. So my resource responds to a get, and if I open this up, we see that the integration request is currently a Lambda proxy. So if I go over to, if I run this as a test, I can actually execute this locally right here through my browser, right? So I click test, and then I give it a query string of zip code equals 20171, and then I scroll down and hit test. And then this will actually invoke my Lambda function and give me, that mock weather, that set of weather data.
All right. And to be clear, you said test this locally, but locally means when you're running it here, that's running on AWS resources.
Yeah.
Okay.
Sorry. So this is actually now executing live in AWS. So I can actually show you how that works by going over to my stages section, opening up my production stage, and then I get this URL here. So this is actually a live URL that any one of you could hit in your browsers and test this application. So I'll click on this, and it's telling me missing authentication token. That's because I have not specified the correct path. So the path is get weather, and then now it's going to say location not found because I need to specify that zip code. So !, zip code equals 20171. So this is actually a live execution all the way from my browser making a GET request to API Gateway, which forwards it to my Lambda function using a proxy integration, and then my Lambda function generating that mock response back to me.
And that was fast.
Yeah, very fast. So if I
Really
refresh this.
And I love here that if you guys notice as George is coding, this shows you the developer caliber. He knows the errors before they even happen. I would have said, why isn't that working? So yeah, well done.
All right, so back to you, Eric.
Okay, so here's a question I have for you. When we did this, you built this out. I'm going to bring this back over to me here. You built this application, but it was a proxy. Okay.
Yeah.
So what I want to talk through a little bit, one of the things that we get a lot of questions on is what's the difference between a proxy and an integration? What is a proxy? What is an integration? And I'm going to kind of lay it out pretty simply, but I think it's one of the most challenging things that people deal with when they're wondering about how does this work. So let's look at this. So when we look at a proxy, when your client requests, when your client makes a request, the request has a certain shape, and that's defined by the client, right? And so it hits API Gateway, and all API Gateway is going to do is it's going to wrap this request in a wrapper that has some contextual information about the request, other than the request itself, metadata around the request. But other than that, it's not going to do anything to the request. It's just going to push it right through to whatever service we have on the back end. I didn't put a service here because it could be any number of services. One of the misnomers about API Gateway is it has to connect to a Lambda, but that's actually not true. And I'm not even sure misnomer was the right word, but I'm going to stick with it at the moment. But what you can connect API Gateway as a proxy to a lot of different things, or as an integration actually to other services. So in the proxy, the request is passed through directly without modifying it other than a wrapper. In the response from whatever service is behind it, it's not going to do anything to the response. It's not going to do custom erroring. It's not going to do any modification. It's not going to model the data in any way. It's just going to pass it right back out. So this would really be that idea of kind of an HTTP bridge. However, when we talk about integrations, you think about that word, is we're going to integrate and do more here. And so let's talk about how that works. So when a request is made to API Gateway, there is the velocity template language that is used, and it can modify the request. So that request can look very different on the back side of API Gateway than it does on the front. Okay, so we can change. So a great example of this is, let's say I have an API that we're running, and we want to change how that works. We want to update it, but we don't want our clients to know. We need our clients to just continue cruising along. Okay, so what we're able to do is take a request in the old format that the client sends, modify it using DTL, and then push that request to the service behind. And as you'll see in a few minutes, coming back, we can remodify that to look, in the certain shape that request should be coming back to the client. And with the velocity templating language, I mean, there's some conditions you can put in, there's logic, there's a lot of different things. Also at the integration level, you're able to, look at the template or the request coming in, and you can model that as far as, does it match a certain model? No, let's drop it. Does it have a certain, you can validate that data coming in as well as modify it. So when you look at the response, it's the same thing. So the response is sent back from the service behind API Gateway. It goes through the velocity templating, and you get a response that could look somewhat the same or not the same at all, and then it's sent back to the client. So that's pretty much how if you think about this, kind of a basic format, this is how the difference between proxy and integration can be explained. George, what I'm asking you to do is, can you change what we've got from a proxy into an integration?
Yeah, absolutely. Let me take over the screen and show you how that's done.
Show me the code.
Yeah. All right. So, okay. So I'm actually back on my API Gateway console. So I've clicked on the get HTTP method for my get weather resource. And remember, notice here we have the integration request set up to be Lambda proxy. So just like Eric said, with the Lambda proxy, you don't have the option to manipulate the payload that goes into your backend. So if I want to manipulate the payload, I'm going to click into integration request here. And this is where I can see all the possible integration types. So Lambda functions, HTTP, any hard-coded mock response, any AWS service, and a VPC link. So a VPC link is one of those cases where you want to execute a private resource within your VPC. But notice this is checked here, use Lambda proxy integration. So if I want to make this a non-proxy, all I have to do is uncheck this. And this little pop-up box is just confirming that I do want to make this change. Click OK, click OK again. And in just a couple seconds, we'll have flipped this from a proxy to a non-proxy. And when I do that, notice on the bottom, we have a few more options that are available. Now, the most important piece here is mapping templates. So a mapping template is where I have to create a velocity template. So if you're familiar with VTL templating, it's JSON, JavaScript notation. So I need to create a mapping template that's going to tell API Gateway what kind of payload to push to my Lambda function. So I'll add a template, and for the content type, I'm going to choose application JSON, click the little checkbox to confirm, and click yes here. And at this point, I have an empty box. So here I can create any JSON template that's going to be pushed to my Lambda function. But right out of the box, API Gateway gives me a really cool option, is just a method request pass-through. So if I click on this, it'll give me a pre-generated velocity template that will basically capture everything in the request and send it to my Lambda function.
Hey,
So
can you expand that window so we can see a little bit? Yeah, blow that up
yeah,
so we can look at that script, if it'll
yeah,
let you.
right here.
Yeah.
Yeah. Yep.
Yeah, that'd be great.
Yeah, so this script is creating a couple different JSON attributes, right? So it's going to create stuff like the parameters. It's going to create the stage variables. Also give me a context object that I can parse through if I need it, which is going to contain all kinds of information about who invoked my API. And then basically take this information and pass it down to my Lambda function. Cool. So I'm going to make the screen a little smaller so we can see what we're doing here. So when you make that change, you have to remember to save here. So I'll click Save, scroll back up to the top, go back to my primary authoring pane here. The next step we have to do is notice the method response has also changed. Now we actually have to determine what kind of HTTP status code to send back to our invoker. So before, a proxy integration will pass through whatever status code that our backend sent out. So now I have to click on this and add a response of 200. So this is just a standard 200 OK. If I were building a real application, I definitely would want to add other status codes that represent different error codes for my app. So 400.
Yeah, you list up each option, right?
Exactly, yeah. I would add 400s, 500s, anything that matches my application.
Okay, cool.
Cool. So go back here. Now we're pretty much ready to test. So I'm going to click test right here. And in the query string box, I'll pass in the same parameter, zip code equals 20171. And this little test button, I'll click test here. And I'm actually getting an error. So it says status code 404, body error, location not found. So if we look down here in the logs, this kind of will give me an idea of why that error is occurring. So this is the execution log. And this is actually going to show me the request that went to my back end. So it sent a request that had a JSON body, a parameters, a path, a query string, and a bunch of these context parameters. So notice we have a query string attribute with a zip code of 20171. So if I go over to my Lambda function, my code is looking for event.queryStringParameters, and that's not really the right location. So I need to edit my application to look for the right JSON path to be able to parse the correct zip. So I'm going to comment line 49 out. I'll copy it, and then I'll put in a new piece of code here. And instead of doing event.queryStringParameters, I'll do event.pathParameters.zip. And notice I'm editing directly in the Lambda console here. So I'm able to hit save, and immediately this will update my Lambda function in just a couple seconds.
So do you recommend live editing like that?
That's a good question. Live editing like this is really quick and really kind of not recommended for production use cases. So production use cases, yeah. So you should probably be going through a full-blown CI/CD cycle with code reviews and check-ins if you're doing actual code that gets pushed to production. But for simplicity, this is kind of like rogue live editing here.
I will
So,
not tell anybody.
cool. So now line 50 has our updated code, zip. We're going to pull it from the path parameters object. We'll go back to API Gateway and go back to here and then click test. So I got location error not found. Why is that happening? Anybody know why that's happening?
I missed the error.
So I'm getting error, location not found.
Ah. Is this one of those where you know the answer already?
I do not actually know this answer.
Okay. Interesting. Alrighty. Looking at that. What about? Did you save you check your VLTs, your script, velocity script?
So looking in here, basically, let me flip back here. We're pulling event.pathParameters.zip, right?
Right.
So
We're not path parameter yet. That's the wrong line.
we're not path parameters yet. Yeah, that's correct.
That's right.
So we probably want to pull zip equals event dot path dot zip, right?
No, it's in the query parameter. I think it's in the
query string.
Yeah, there you go. There you
Query
go.
string. Yep. So query string dot zip. Hit save. And let's test that again. So hit test. We're still getting location not found.
Yeah, let's look at that. So it's path.queryString. Not is event.path.queryString. Is that what I'm seeing there?
Params.
Or params.
Yeah. Event.params.queryString.zip. Hit save again and click test right here. So we're still getting location not found. That's okay.
All right. Well, here, let me, I'm going to jump out. If you want to look at that real quick, and I'm going to talk through the SAM stuff, or do you want to continue on what you're doing? Or not SAM stuff, but integration stuff.
I think we're going to flip to a different requirement, right? Instead of using query parameters, we'll do.
Yeah, well, so that brings up my OCD, and we'll fix this problem in post while we figure that out there. But here's my OCD, okay? So I'm not a path parameter guy. I'm not a query string parameter. I'm a path parameter. I like that. I think it's cleaner. Can you do path parameters inside of SAM or inside of API Gateway rather than using query string parameters?
Yeah, definitely. So if our requirements change and we no longer want to pull the zip code from a query string and we want to pull it from a path, that change is pretty simple to do. So why don't I flip back to my local development environment and show you how that's done.
And you're not sharing anymore that I see, so you're screwed.
Yeah. Okay. Cool. So here, I'm going to make a couple of changes. So the change I'm going to make is I will go to my application code and I'm going to go to my template.yaml. And instead of my get weather here, I'm going to attach a /zip. So the /zip with curly braces around it indicates in the path that this is going to be a path parameter that's going to be passed down to my Lambda function within the event object.
Nice.
So make a save real quick right here and flip back to my application code. And this is where we have to make this change on line 50. So instead of capturing from query string parameters, I'll capture from path parameters. and I'll still capture the same parameter, .zip, right? So hit save here, and now I updated my code and my template, so I have to do a SAM build again. So when I do a SAM build down below in my terminal, it's going to go through the process of regenerating all the dependencies and zipping and pushing all the artifacts into my .aws SAM folder. And now I'm ready to do SAM local start API. So this again will boot everything, API gateway and Lambda, run it locally. And now we kind of see a little bit of a difference here. We see a /get weather, but this time we see a curly brace zip. So this represents a path parameter that I'm going to expect instead of a query string parameter. So in here, instead of doing a query string, I'll do 20171, and so
we can't see your browser.
You can't see my browser.
Nope. Just seeing the code still.
Let me try to reshare.
Yeah, when you shared, you might have just shared the screen or the window instead of the screen.
Okay.
There we go. Perfect.
Cool. Can we see it now? All right, let me rerun that. So get weather, if I were to leave this off, it would say missing authentication token. And this is just our default error message when something in the request path is incorrect. So if I were to say /20171, instead of a question mark zip equals 20171, this will invoke my application, pass down the parameter using a path parameter instead of a zip parameter. So the code's executing the same, we're just pulling the information differently from a different source, from a different HTTP parameter.
Let's see, my personal opinion is I think that looks cleaner, but that looks great. So you can do path parameters or query string parameters. Can you mix them?
Sure, you could mix them if you want to. Yeah, it gets complicated, but you have the option of mixing them.
Okay, and we'll be talking about later on when you're doing the parameters and query string or path parameters on caching those and caching strategies to make those work. So we're running out of time a little bit, but I wanted to talk about one other thing, kind of going back to the whole proxy versus integration. And I know we had some problems fixing the code. Live coding is always fun; it's the risk you take. But one of the things is we updated that through the console. We didn't do it in SAM, but I want to show that that's still something you can do through SAM. And George, I won't quick test you on building that out. But so what I want to kind of show is what would that look like if I were to build this out in SAM. And it's really not it's not a big change. So if we go back to the very beginning of the session, we have this hello world function that was generated. And yeah, it is Node. It is a Node app. You'll see in here under the events, we have the hello world event. It's an API type and properties, path, hello, and the method get. In order to change that so that we can do a proxy, because we can do an integration, there's a couple of steps, but just so you know, anytime you do it this way, it will always be a proxy, okay? If you want to do an integration, then it would look something like this. Where two things. First of all, we add a separate API into this. So we're going to do a separate API as a resource. And normally in the template, this will be below, but I wanted everybody to be able to see this. And so we did separate API. Again, it's an AWS. This is one of these serverless resources. And properties, all I have to pass are a stage name and a definition URI. And that definition URI can be a link to a file, like a file path, or it can be an S3 location. The second thing we need to do is under the properties, we're going to add a REST API ID because we still need that event to happen. Okay, we still want that event to trigger the function. So we keep this event, but we add an API ID so it knows, okay, use this API. And so you can see the changes there. You can also, if you want to get crazy, instead of linking, so this definition URI, which is the last line on the right side, instead of linking to a file, you could actually do a definition body right inside of this. And so you would do your definition body, and then you would have and this happens to be YAML. This also works in JSON, and you would define your API gateway through that. And so then obviously, with an integration, you have a lot more flexibility and you start really being able to take advantage of how to do these. And one of the things that George, we didn't get a chance to show is when you build out, like let's say we took George's integration and we said, we want to get a hold of that Swagger. Well, and we mentioned this in episode 1, you can export either OpenAPI or Swagger templates right out of API Gateway. So one of the tricks that I tend to do is I'll build what I want my API to look like through the console. And I build out maybe the authorization and the different things that I want it to have, and then I'll export that Swagger template. Now, you may ask yourself, well, why would you do that? If you've got it built, you've got it built. Yeah, but I like infrastructure as code, and I like to be able to move it around if I need to, or copy it or edit it in a versioned manner. So what I can do is I take that, I put it in here, either in my definition body, or most likely I'll import it from a Swagger file. And then that's built it out. Rather than having to build that whole Swagger template from zero, you can export it right out of API Gateway and then use it as a definition, and then you can modify that as you go. It's a great way to start out. George, anything you want to throw on that?
Yeah. So why don't we take a look at really quickly how to do that?
Okay.
So I'm going to share my screen again, and so I've clicked into my deployed API Gateway API, and I've clicked into the stages section, and I'm using my production stage. So notice we've got an invoke URL right here that any one of you could go and test. But then I have a bunch of tabs here, and one of the tabs is an export tab. And I can export this using either a Swagger or OpenAPI 3 definition, and I can choose JSON or YAML. So I know we had that little debate of who liked JSON, who liked YAML, but I'm going to go with YAML. So I'll click on YAML, and it downloads that file to my local machine, but also gives me a preview right here. So right in line, this is a Swagger 2.0 template, and zoom in a little bit for you. Notice here that it defines pretty much everything about this API. It defines that there's a single path /getWeather. GetWeather will respond to a get HTTP method request, and then down here we're just telling the Swagger template is telling us that the integration backend is going to be a Lambda function, and that Lambda function is represented by this long ARN right here. So when I have a lot of different integrations, or if I'm working with different developers, the idea is to create your APIs and document them using Swagger templates or OpenAPI. That way you can source control, version control, code review, and do all of the things that the normal development process would go through.
Yeah, I agree. And if you're curious about the difference between Swagger and OpenAPI and that conversation, I encourage you to go back and watch our first episode where Alan Tan talks through that. It's pretty straightforward. Okay, well, we're almost out of time. So what I want to do is encourage you guys. The next session we're going to be doing is on May 14th, and Bob Kinney will be joining me. If you like my beard, really just a goatee, you're going to love Bob's. His is I'm jealous. That's pretty much it. He is one of our API Gateway experts as well, and we're going to be talking about the all-seeing eye over Amazon API Gateway. And really what that means is how do we demonstrate, how do we monitor, how do we log, how do we debug? And so some great tips on finding bottlenecking, on finding failing, much like what we were just dealing with earlier. How do you find those errors? How do you remediate those errors? How do you avoid them next time? So I encourage you to join us on May 14th, again 1 p.m. Pacific time. Looking forward to it. If you want to know more, you want to follow, or even maybe we'll post a solution to what was hassling us earlier, I encourage you to follow at EDJ, I can't even say it, EDJ Geek. That's my Twitter handle. And George, you want to tell yours? It's not on here, but you want to throw yours out there?
Yeah, my Twitter handle is just my name, George Mao. So feel free to tweet us, let us know what you think. Any questions, send them our way.
With that, guys, we're out. Until next time, I appreciate it. Stay calm, stay peaceful. API on.